Okay, I've had a few requests to go over this problem, so I'm going to take some time to explain it to you guys. Now, first of all, do not be intimidated by fractions. This is still just a regular quadratic function that we've been doing. The only difference is you have fractions involved. So, let's take a look here. First thing I should do, I want to find my vertex. So in order to do that, I got to use the formula h equals negative b over 2a. Alright, so now I plug in my values. Or first of all, I should probably identify these values. A equals 2/3, B equals 1, and C equals negative 1/3. Alright, I'm not going to end up using C here, but I'm going to plug in what I've got. So I plug in negative B. So since B is 1, I'm going to pop it in parentheses here. It's important to do that. Thing is, if I have a negative that I pop in there, it's good so I can see the two negatives. But in this case, I just have a negative on the outside, positive on the inside. Now on the bottom here, I'm going to do 2 times a. So 2 times, now a is a fraction. Uh-oh. We don't like these, but don't worry, we can handle it. Alright, so negative on the outside, and then you got the 1, so this just gives you negative 1. Now, you have to multiply these. Now, if you remember, got a whole number, just pop a 1 underneath it, and since it's a fraction, we just multiply straight across. And you get 2 times 2 gives you 4, and then 1 times 3 gives me 3. So now I have negative 1 over 4/3. And this is where a lot of people are getting mixed up. They're like, wait a second, you can't have a fraction on the bottom. Yes, you can. It's what's called a complex fraction. It's when you can have fractions within fractions. You can even have fractions within fractions within fractions. So don't be intimidated. Now, what's important to do is you want to identify this bad boy right here in the middle. You have this line, right? Now, typically we always think, oh, that's a fraction. But I always like to think of a fraction as just being a lazy person's division problem. A fraction is just a division problem that hasn't been solved yet. So, since this is a division problem that hasn't been solved yet, I'm going to solve it because I do not want a complex fraction within my vertex. It's just messy. It's already bad enough I got fractions in my vertex. I don't want complex fractions in there. So what this tells me is I'm going to have... Oh, I don't want to use that color. Alright, so I'm just going to erase. There we go. Alright, back in business. So this is going to be negative 1 divided by 4/3. Alright, see a fraction? Don't be intimidated. We copy, switch division to multiplication, and we flip. Alright, so now I just have negative 1 times 3/4. 1 times anything always gives me itself. Just pop a negative in front of it, and boom. I get negative 3/4. So now I have my x value of my vertex. H equals negative 3/4. Alright, so now I just have to carry that over so I can solve for k. Okay, so if you remember, we have h equals negative 3/4. So now, I have an input, because h is just the input of my vertex, or the x of my vertex. So I want to get my output. So I'm going to plug in my input. 2/3, and then parentheses. Negative 3/4 squared plus negative 3/4. I like using parentheses here, because that way I don't mix up any of my signs. And then minus 1/3. Now, first things first, you might want to do 2/3 times negative 3/4, but don't do that. Don't do that. First thing you gotta do, order of operations tells you parentheses or grouping symbols. We don't really have those, but next we have exponents. We're gonna deal with that. So I'm gonna do this. Now, remember, that's not negative 3 times 2. That's negative 3/4 times negative 3/4. Doing that out, I get 9/16. So remember, all you got to do is multiply straight across when you're multiplying fractions. So then I've got 2/3 times 9/16 plus negative 3/4 minus 1/3. Alright, next thing I got to do, multiplication. Now, here's what I like to do. I like to cross-simplify when possible. If you're multiplying fractions, you can cross-simplify, makes your numbers a little less intense to deal with. So I look at the numbers directly, diagonally from each other. 3 and 9, they have a factor of 3 in common. So I'm going to divide 3 by 3, gives me 1. 9 divided by 3 gives me 3. Alright, now I'm going to do the same thing to 2 and 16. Can I use a different color? Heck yes, I can. Nice. 2, 16. Alright, they have a common factor of 2. Divide 2 by 2, I get 1. 16 by 2, I get 8. Now I can just multiply straight across. 1 times 3 gives me 3. 1 times 8 gives me 8. Now bear in mind, you don't have to cross-simplify. It just makes your numbers a little smaller and a little less intense to deal with. So now I've got this. Now, this is an expression, so I can't exactly clear my fractions, but I do need a common denominator. So between 8, 4, and 3, I got a common denominator of 24. To get to 24, I'd have to multiply 8 by 3. So I got to do that to the top. Got to do it to the bottom too. Fractions are jealous, as I like to say. If you do something to the top, you got to do the same thing to the bottom. I'm going to do 4 times 6 because that gives me 24. And over here I'm going to do 3 times 8 because that gives me 24. Alright, so 3 times 3 gives me 9. 3 times 8 gives me 24. And then over here, I get negative 3 times 6, I get negative 18. 4 times 6 gives me 24. 1 times 8 gives me 8. 3 times 8 gives me 24. Alright, I'm almost there. 3. Now, what am I saying? 3. I'm not dealing with 3 now. I am dealing with my numerators. Now my denominators stay the same, so I'm going to do 9 plus negative 18, gives me negative 9 over 24. So I get negative 9 over 24 minus 8 over 24. Negative 9 minus 8 gives me negative 17 over 24. So now I have the vertex of my function. Negative 3/4. Negative 17/24. Can that happen? Absolutely. You can get fractions. Do not be intimidated by fractions. Just because you get fractions does not mean you did it wrong. A lot of people see that, they think they did it wrong. And yikes, I want to get out of here. Alright, cool. So if you get to this point, you're like, oh my lord, what did I do wrong? You didn't do anything wrong. Fractions are okay. You're going to get them, especially in algebra. Not everything's going to come up to a clean answer, so we've got our vertex now. Now going to the next page. Alright, so now I have a vertex. Now, once you get your vertex, just make a table. So I'm going to make a function table right here. X and Y. I'm going to put my vertex right here in the middle. Now, in a perfect world, you want to get number of values so you can get a nice looking parabola. However, in this case, for the sake of making things a little easier, we're just going to go with an additional 2 points, and that'll give us something to go off of here. Now, it's not the worst idea to get 2 points that are going to be equidistant on each side of your parabola. But I'll show you what I mean. Now, I'm going to draw my parabola here. Notice I got a little graph here. I make my X and Y axis. Now here's where people say, Mr. Gamache, how do I graph this vertex? It's all fractions. Well, think about it. Negative 3/4 is between 0 and negative 1. Negative 17/24 is between, again, 0 and negative 1. So you want to just kind of ballpark it. So in the x-axis, I want to go about, somewhat close to negative 1, but not quite there. And then negative 17/24, it's kind of a little more than half. So if I put a dot right here, it's not perfect, but it'll do for what we're doing. Now I want points on this side of the parabola and this side of the parabola. So that's what I'm going to do. Now, as I said, in a perfect world, it's always good if you can make them equidistant. But since we're dealing with some nasty fractions here, and for right now, we just kind of want to get some sort of parabola going, it's okay if you just go with a couple of easy values. So I'm going to go with an x value that is greater than negative 3/4, which is nice and easy. I'm going to go with 0. When possible, I love using 0. So now I just plug in 0 into my function. 2/3 times 0 to the second power plus x minus 1/3. Oh, and I can get rid of that x now and just plug in 0. Well, let's see. 0 to the second power, 0. 0 times 2/3, 0. 0 plus 0, 0. 0 minus 1/3 gives me negative 1/3. So I'd get negative 1/3 right here. So I'm going to go to my origin 0, and I want to graph negative 1/3. I can put a dot like right about here. Not perfect, but it'll do. Alright, so the next one I'm going to use is negative 1. Why? Because it's nice and easy. Alright. Okay, so now what we're going to do is we're going to plug in negative 1. This is my third time doing this, actually. I did this twice, and I forgot to hit the microphone button. So, hey, third time's a charm. Alright, so negative 2/3. I'm going to plug in negative 1. I'm going to square it. I'm going to add negative 1 minus 1/3. Alright, so negative 1 squared gives me 1. 1 times 2/3 gives me 2/3. So now I have 2/3 plus negative 1 minus 1/3. Which is really just adding the opposite, so I'm just going to change it to plus negative 1/3. I like to deal with my terms like that. Alright, now what I'm going to do first is I'm going to do 2/3 plus negative 1/3, and that gives me 1/3. So I have 1/3 plus negative 1. Negative 1, I can just rewrite that as negative 3/3. Let's add that together. I get negative 2/3. So I get negative 2/3. So I'm going to try and ballpark that. It's not going to be perfect, but I can put it right about here. You might be thinking, why does this parabola look so nasty? Well, the thing is, we didn't exactly go with some perfect points here. If we wanted to get a really good-looking parabola, we would have wanted something, or 2 points that were equidistant from negative 3/4. For right now, though, we just want something... excuse me. We just want something that we can look at, something we can graph, something a little tangible. Now, next step, we're going to be looking at this as we go a bit further on. We'd be finding x-intercepts for this. For right now, though, you don't necessarily have to do that. So for right now, we're just going to keep it as a fairly ugly-looking parabola. The important thing is, I just don't want you guys to be intimidated when you see a fraction involved with a quadratic. It's not the worst thing. It is possible. It can be done. Don't be intimidated. You're going to be seeing more fractions as you move further along, and especially when we're going to be doing x-intercepts. You're going to see more fractions. But hopefully this gave you a nice little explanation of how this is done. Hope it helped. Boom. How about that? Alright. So now I just got to erase some stuff. Where's my eraser? My lord. Alright, I can do this. There we go. Eraser. We're going to erase. I'm going to erase all this because you know what? I already did it. What the heck? It's not erasing. What? Alright, forget that.